Test 1 2. Test 1 2. Hey, why am I getting that?
Apparently it's a black screen, but it says it's live.
Can you bring it up on your laptop? 1 2 1 2 1 2. Recording. Thank you for your patience, everyone. Let's get underway then. Oh, well, before we do, we've got some more. We want some DVDs. Hands up for some DVDs. Here we go. What's a DVD? How do you read them? What do you have? Thanks. Notes. Oh man, thanks. You got one? Alright. I think that's good. You know, it's in space if anybody wants to pick one up, they'll be right here on the way out. So, yeah, that's true. Take it away, Neil.
Okay. Good evening, everybody. India. I would like to welcome you all to the 9th monthly Cyberspectrum Meetup. This event serves as a forum for knowledge and ideas related to software-defined radio. It really aims to get people interested and excited about the applications that can SDR technology. Engineers, students, hobbyists, enthusiasts, and people of all experience levels are welcome, no matter or a hardware background. At each meetup, the community will have the opportunity to present projects and ideas to the event here tonight is being hosted and sponsored by Edis Research. The first speaker will be Martin Brown, who will kick off the first of a series of short news updates with information about developments related to GNU Radio. Our second speaker will be Tom Tsu, who will give a talk titled A Guided Tour of LTE on SDR. Tom will speak about LTE fundamentals, the many available software stacks that can run with SDRs, what capabilities are there, and what the future holds. He will also do a live demo. Our third speaker will be Kevin Reed, who will talk about some suggested enhancements and new features for GNU Radio. And our fourth speaker will be Moritz Fischer, who will provide a brief update to the talk that he gave back in May titled Decoding DECT with GNU Radio. All meetup presentations will be recorded and posted online, as well as streamed live on YouTube. The previous 8 events have already been posted in full HD video. We have set up a channel on IRC called #Cyberspectrum on Freenode as a way for people remotely watching the live stream to contact the group here in Santa Clara with any comments, questions, and alert us to any audio-visual problems. Future meetup locations will alternate every month between the Edis Research Office in Santa Clara and Noisebridge in San Francisco. However, the next meetup will be tentatively held on Wednesday, August 20th at the GNU Radio Conference in Washington, D.C. Further details will be posted on the meetup webpage shortly. Please tune in, pun intended, for more information, as well as for a list of speakers and presentation topics. This meetup series will return to the Bay Area at Noisebridge in San Francisco, tentatively on Wednesday, September 30th. As always, if you'd like to present something or you just have ideas about future topics, please let us know. We would thank all of our speakers tonight for their efforts and their enthusiasm, and we would especially like to thank Edis Research for providing the space and hosting the meetup here tonight. Free pizza, soda, and beer are available in the front lobby and in the refrigerator, courtesy of Edis Research, so please help yourself at any time. Without further delay, let's get started. Balint will make a few additions and then introduce our first speaker. Thank you.
Thank you, Neil. So again, thank you for your patience this evening, everyone. I'll just do my usual spiel very briefly. Welcome to number 9. It's incredible to think that it's been 9 months since we've started, and it's always wonderful to see such a turnout. It's really for those of you that are here that want to communicate during the presentations, or to those people out there, please hop on to the Cyberspectrum channel on Freenode. I have quite a few people there, and the signs are all good. Are they still making fun of me, or
No.
they're happy now?
It's better. I think they'll always be happy.
All right. Oh yeah. Thanks again to NS Research for pizza and beer tonight. And remember, if you can spread the word about Cyberspectrum, let people know that this is the meetup that we have, and anybody's welcome, no matter what their skill level, no matter what they want to talk about, whether it's a finished project or something that's in progress. This is a great group to get some feedback from and to run ideas by. So please feel free to get in touch and submit a talk. As usual, after the event, various links and materials and videos will be posted on the Meetup page. If you go to Pages, then you can see, this is obviously a very old screenshot, there are many more Meetup links there, but they will link to individual pages where you can access people's presentations and slides and resources. So that's actually wrong.
Normally it would be
Normally.
city.
Like giving to our routine, it would be in San Francisco. However, during that time, we will be at the GNU Radio Conference. Very exciting. Jonathan, how is that coming together? Actually, can I put you on the spot? Would you like to do a bit of a plug for the conference? Or you can relax down the back, that's all right. But we have this conference happening. It's grown incredibly over the past couple of years. It's just a fantastic week-long event where people, again, of all skill levels that are interested in SDR and using this open source framework and getting into the open source SDR ecosystem can come along, get involved, hear about all the cool things. And that's really, really neat. And we just had the brainwave thinking, well, Cyberspectrum is usually on in that last week. Maybe we could do something impromptu from there. But it's just an initial thought. We'll see what happens. There'll be presentations, tutorials, hands-on, a hackfest, and it's going to be a great week, so if you can get out there, please do. So tonight then, we have, if you want to take note of these Twitter handles, Moritz Fischer. Moritz, where are you? Hello. Sorry, it's the old picture. I made a complaint about it last time. But at least you're smiling. And we have Martin Brown. Brown noise. Kevin Reed, where is Kevin? Hi, Kevin. Kevin's back. I'm sure we'll have some more amazing stuff. And our new presenter for this time, really exciting LTE with SDR, Tom. Tom is over there. And he has this incredible setup that he's put together with quite a few different PCs for some cool live demos, which I'm really excited about. So without further ado, we can get started.
No. Question from my IC is, if we do a Cyberspectrum in DC, is it only for GR1 activities?
Generally like to keep it open, so
Probably not.
anyone can come along. That's the idea. That's what we're going for. I mean, it'll be nice because it's in that milieu. So yeah. So speaker number 1. I'd like to take the stage.
I'll be mentioning GR1, by the way. If that helps.
VG?
It's fine. Cool. Thanks.
Usually takes a moment.
Okay. Thanks, Balint. So, will become a regular thing. It won't become a monthly thing, like Neil just said. But that's fine because he's marketing and he always oversells what R&D does. So, I don't know. This is new, so maybe we'll figure out a good rhythm for this. I think monthly, because there's just not enough to mention every month. And also, like in the future, I hope I can get this a bit more flashy. Maybe some, Fox News style is what I was thinking. presenting live from wherever. I'm not quite there yet. Today I'll just be presenting facts, raw and boring, as I do in my German way. Okay, so oh yeah, okay, so that's so quick. I'm not gonna repeat myself here. Okay, so first item I want to bring up, GNU Radio Conference. So if you do not have a ticket yet, there are still tickets available, and it'll be in Washington D.C. It's that Alan just alluded to, where there will be a Cyberspectrum on, I forgot the date, but it's probably the Wednesday then, right? Yeah. So in the week from the August 24th to the 28th, the first and the last day are a bit special. One of them is the New Users Day, specifically targeted to people who have no prior experience to GNU Radio, who want to get more exposure, but they don't want to go straight into the deep technical talks. And the last fest, there's no talks or anything scheduled. We're just going to use the venue to work on stuff, and especially for beginners, that's really good because there's going to be a lot of people just on their usurps and on their GNU Radio's codes, and you can walk up and ask them stuff. And it's not like a week-long hackfest project, so intended for that purpose, where you can ask the experts for help. And the rest of the conference, that might be a bit difficult because everyone's sort of tied up in the actual presentations and whatever else we have. So the conference will be chock-a-block packed with presentations and demos and tutorials. For example, Jonathan is talking about RFNOC and myself as well. And there'll be talks about, I know, folk, GNU Radio, everything is, it'll be crazy. Like, this will be a really, really good conference. I'm really looking forward to it. And I hope I'll see many of you guys there. So one sort of side note, we have our monthly on the 3rd every month. You can tune in. Like these Cyberspectrums, they get streamed. However, we will in August, maybe the one in September. I'm just putting it out there. So GNU Radio Conference. Any questions on GNU Radio Conference? No. So we have a new release. Actually, that's not true. We have a release candidate. And Jonathan has frozen the master branch. And in a few weeks, so actually on August, we will hopefully have a release, like barring like major issues which usually don't occur. So I wanted to sort of summarize what's going on master branch, but there's like 137 unique new additions to whatever we had on main. That's just too much. It's lots of things happening, really exciting, especially if you're using Qt and control plot stuff. I definitely recommend up. In all other cases, it's probably useful as well. The Git repository. And by the way, Jonathan's also giving classes on GNU Radio. So usually, so he's also giving classes where you can sort of just register as an individual and come. There's actually going to be a new set of these on September the 3rd. Here in this room or the one next one. Folk. Who does not know what folk is? Please raise your hand. Oh, there's actually quite a few. So Balin doesn't know what folk is. I'll explain. I don't mind. Folk is the vector-optimized library of kernels. It used to be a component in GNU Radio. We make it possible to use operations to accelerate your DSP. Welcome. And eventually it became its own thing and it's its own project. And Nathan is the maintainer and just recently tagged the 102 bugfix release. And you can use Volk for your stuff even if you're not using GNU Radio. I definitely recommend looking into it if you need, fast acceleration on your GPPs. And this version apparently supports ASM protokernels. That sounds so cool. I put it in this slide. I don't actually know what that means. Don't explain it. That destroys the mystery. The mystery, yeah. It sounds like something from a science fiction movie. So UHD, a lot of things are happening on UHD. We have a new main release. We had 5 recommend upgrading to that. But for those people who are following what's happening on master branch, merges going on. We've had some demand for a C API, so we put some wrappers in there so you can just use C code. to write UHD apps, and a lot of things are going on, and UHD has managed to now get Python 3 compatible. We're still getting there, we'll get there. UHD has already managed to do that. PyBombs 2 is a project that I do not recommend people use for production. It simply doesn't work yet. But it's gotten to the stage where you do things with it, as in install stuff. Now, if you don't know what PyBombs is our GNU Radio package manager. So it's what pip or npm or gem or apt-get-off or their respective counterparts. PyBombs 2 differs from in many ways. It's basically a rewrite, and it adds the capability, for example, to have multiple recipe locations. It handles different prefixes better. Cross-compiling support will be in there, so that'll be very easy for all those people working on embedded devices. I'm actually one of the guys working on this, and we do appreciate help. There's lots to do, so it's pure Python. If you want to help, chip in, write some Pythons, and maybe you have your own little system you want to support. So, for example, I was just talking to Chris earlier about a brew or MacPort's backend. We know, we have the capabilities to put those in there. We just don't have them yet. So any code contributions are highly appreciated. And something I wanted to mention on the site is Sora is now also open source. I don't know, has anyone heard of that? So it's Microsoft's SDR. No one actually uses it as far as I know, except for research team. But it's it's interesting. You can go to the GitHub page and look how they solve stuff. It's very Windows centric.
So
I'm gonna try and hide my excitement.
Just a quick note. Technically, it's not fully open source because by the license, it has anything you develop has to be used on the Mango Communications platform, the Sora platform. Just throwing that note out there.
Yeah, but the codes are there for your perusal, so I think that's probably the most interesting part of it. I don't think people will start porting their stuff from the radio to Sora. Yeah, so that's it. As I mentioned before, I'll be sort of trying to collate stuff and make this sort of more accessible in the future. You have something that you want to, you don't want to come to the Cyberspectrum talk about. Just want someone to announce it. Drop me a line, and I'll try and make it as exciting as possible. Okay, thanks a lot. And who do I hand the mic back to? Neil.
Thanks, Martin. We can now expect this update as a regular feature.
Absolutely, yes.
And you came up with a catchy title for this segment.
So right now,
live to Martin.
So right now it's So that's the one reported live from the Free Software Bulletin. Handed it back to the studio.
Thanks very much, Martin. All right. So let's jump into our next speaker then. We're going to head straight to the land of LTE.
Surprise.
All right. Let's mix it up. Let's mix it up and take a quick detour.
You get like 5 minutes.
We're going to.
Laptop.
That's all right. Obsolete wireless protocol first. Do you need?
It's kind of obsolete, I agree.
Do you need an adapter, or do you want to try the HDMI?
This Apple work, right?
Sure.
I have the adapter you need.
I might not use.
Well, it's waiting for HDMI, so we won't go. Oh, there we go. There we go.
Alright, so first of all, like last time I talked about that, I was alone. Now Martin's here. He's kind of my partner in crime on that. So at some times ago, I talked a bit about DECT, which is or DECT. This like a quick update, so I'm not going to say everything again I did already. And I have a portable demo last time. I had a demo running on my desktop in the lab over there. So just quick, what is DECT? Something you're all around here. Apparently people don't anymore. So they're basically cordless phones, the restaurant, credit card terminals, those kind of things still use DECT. in Europe. Disclaimer, we have no idea what we're doing, despite the fact of being actually paid to build software radios. And having degrees, we're mainly building hardware to do so, and kind of in our spare time work on that on the side. So this was a fun project, and we tried to see how far we can get without spending too much time on it. So what happened so far, I call it like the duct tape receiver because it's not very smart in design. DECT has like several channels, and since we're lazy, we kind of threw hardware at the problem and built like the simplest, easiest receiver we could think of, and it can receive all the 10 channels of the US DECT has only 5. We can do that in parallel with a laptop and a B200. We get some overflows because we didn't really optimize yet. It's kind of flaky still. So that's some technical data about this a lot. Basically, the total bandwidth we need is about 19 megahertz, and the flow graph to do so is not open. Is open. It's kind of what happens here is like you have the user, you have like a polyphase channelizer that channelizes it into those DECT channels, and you have the burst smarts, and we just correlate on the access code for every single one of them 10 times in parallel, and then we just dump that as PDUs into a Wireshark pipe, which is the update I have for this time. So we can now pipe the stuff into Wireshark, and Wireshark already has, thanks to the DECT project, a dissector. So that's recorded. I can also do that live.
Moritz, would you mind magnifying the Wireshark so that it's...
How does that work?
Just click on the plus.
Oh, wow. You see the hacker, I never use this stuff usually. So that also works in real time. So I created a pipe sync. Basically, I create a pipe in temp DECT test. Fake Ethernet headers, so Wireshark will think they're Ethernet packets and start to dissect them. I can run the demo to do that. Didn't crash, that's great. So now it's running, you see some overflows, you see nothing. Here is like a Siemens German illegal here base station that I brought over from Europe. If I turn it on, you should start seeing packets arriving. And yeah, you can use Wireshark to look at that. And look at the protocol. You see the CRCs are okay. You see the different packets. Here we have like the multi-frame synchronization that comes every now and then. And you can look at them in real time. So that's kind of my update I have. Any questions? What you saw? I mean, a lot of people weren't there last time, I think. Interesting. I'm not good with Macs. Any questions on what you saw? Any questions on what I didn't talk about because I said it last time? No?
Is the code available somewhere?
Oh yes, it's on GitHub and it's embarrassing. But it's on Martin's GitHub, so basically it's not in a release-able state. We just put it there so we don't have to on our machines. But we are going to clean it up, and for GRCon you'll have a real presentation. Yeah.
So I have a question. When you started the script, it said that it was loading something into an FPGA. Is that so the polyphase channel block that you use, that's executed in hardware?
Well, that's all new radios. It's just the B200 here has an FPGA for normal B200 operation. You need to load use the device when you plug it, but all the calculations done on the host. It's like a recently modern MacBook can do that for 10 channels in parallel.
So are you taking 19 megahertz of bandwidth into from the user to the host?
They take 19 megahertz of bandwidth into the channelizer, which spits out my 10 channels at 1.728, and I filter them a bit, and then I correlate on the on the synchronization sequence, and then I tag that with a tagger, and then I just stupidly slice off one frame, one slot, and then make a PDU from that, and this PDU goes into because I didn't want to deal with multiplexing, I just create PDUs and they go into the Wireshark sync I created. All that goes to Wireshark, and Wireshark knows how to interpret all that. So the problem with this, however, is it can't do double slots currently because we just copy single slots every time. So DECT has this double slots. So the DECT frame is basically synchronization preamble, then some header, then your data, then some CRC, and some guard interval, and then the next one. And for a double slot, you don't have a second synchronization sequence. The purpose, and as we just copy, like it's hard coded, we just copy one slot for the moment into the PDU. We kind of lack the second, but we're working on that. All right. Probably kill that. Yeah, it overflows every now and then.
I got a quick question. To modulate all 10 channels in parallel on the MacBook?
Yes. I mean, it overflows quite a bit, but it works fairly well if you look at the timestamps. We're not losing that much. So I suppose if you really want to use that, you can just take a faster machine or look into being smarter.
Can we see your flow graph again?
Sure. That's also in GitHub.
You got some stuff there that's disabled.
Yeah, that was basically what we first recorded to a file, so without usurps at home. Try if it works. Sorry.
Are you doing the channelizing on the Mac or the FPGA?
On the Mac. I mean, at one point we hopefully have a channelizer on the FPGA with RFNOC, but it's not there yet. So, I mean, it would be very ideal for an FPGA implementation because the resulting bit rate you get out of is like 80 kilobits per second. So that would be awesome if you could reduce it to 10 times 80 kilobits per second and do all the processing on the FPGA. Then the host CPU could sleep 90% of the time.
Are all those off the just standard blocks?
Yes. So if you look at how we do stuff, you basically you have a resampler that's we have the GMSK mod, that's a GNU radio block. You have a correlate access code, that's a GNU radio block. Here is the only you had to write, which just looks at the tag, which has like the sauerkraut tag we create here, and you just 420 bits and turn it into a PDU. So it was like literally one file that's required to do all this.
So that's the schematic that's underneath each one of those 10 channels in the
Yes.
top schematic?
Yes.
So it's hierarchical.
So
Okay.
it takes a parameter of the channel index, so then in the end you can kind of figure out on which channel it was, and we attach that as PMTs to go. Yeah, Wireshark can pull up all the metadata. This this Wireshark pipe is kind of a hack because it creates packets, and I do that in Python. So I just open a named pipe and stick on a header and create this pseudo Ethernet packets that have an encapsulation.
Is the P200 powerful enough to be a DECT transmitter?
Oh yes, definitely.
Are you working on that as well?
I wanted to first have something to debug with, so that's why we went for the Wireshark thingy, so we can actually see if the frames we're generating are valid DECT frames afterwards.
And walking is such a strong.
Yes. I mean, this is literally like.
That's the opposite.
This is literally like it's Friday afternoon, 4 p.m. Let's do something fun for an hour, right? And we did that like 3 times, and you end up with that. So
if you push down to that bottom schematic again, the one underneath, if you could put a block early in that path there that was like a threshold detect, you could really bring the computation load down.
yes, I mean you could be a lot smarter also, and just like have a feedback of sorts that just reports CRC errors, and if you get over a certain threshold per channel, then you can just assume that you need, like, now we're constantly correlating. You don't need that.
Right.
You just need to correlate if you're lost, and once you're synced, then you do that until you lose sync. But then you need to be smart. So. But yeah, the peak detect would probably help a lot.
All right. Thank you, Mark. Any other questions? Exciting stuff. Looking forward to it. In fact, it's not even that far away. Heaps of time.
It's like 2 Friday afternoons.
That's just double shit, right?
All right. So now we'll start with our next. We need a couple minutes to set up.
Yeah, I just need to get I'm going to move the presentation over here. So
Okay.
This piece, so a minute or two.
Do you need a dramatic introduction, a build-up?
If you're so inclined. But certainly if you need to grab a drink or anything like that.
Yeah, I was going to suggest if Tom needs a minute or so to set up, why don't we take a break? I actually didn't get a slice of pizza yet, so if anybody else is still hungry, there should be pizza and drink outside. If you need to use the restrooms, just head down this corridor to the left, and you'll see.
But it's cement, so they actually do crypto. You have to get a cheap Chinese one.
Yeah. Or an American one.
Well, the American one is also easier because they have.
Okay.
Yeah, that's all I have. Thing on stick.
And if you
Fix some broken useless limbs. And by that, I don't mean broken out. So
yeah, I was just saying,
broken out.
You brought the beast out here, huh?
Oh yeah. A whole lot of processing power.
Yeah.
A bunch of shit, like, never been flushed out.
oh, okay, that's
You
fine.
know, I decided that, hey, I'll do rap, no strong signal.
So-
So I said to Matt, hey, it's rapping. There's absolutely no way possibly be rapping. I was like, okay. And then a week later, it's like, hey, this is $6, boy.
Here's a simulation showing how
There's 6 different places that are rap. Yeah. Yeah, he's getting used to me playing that game. Unfortunately, I forgot to bet in $20. I lost last time. I was good shot betting this time. I would have won.
yeah.
i7 version.
Ah, yes.
But it also
I
has
do as well.
it also has a TCXO port. Glad to see it just kind of show up.
I think with that, like they all receive. Yeah. Dozens, like maybe even hundreds of these things. Wow. One goes per, I don't know, so much.
I mean, you should have $10 to pay for it, doesn't pay a million about that. Yeah. Let's do a weird stuff, just do a bucket full of it. Mine just those headphones, believe it or not.
I talked
And then you have to wire set.
I don't know why. I'm involved with the directional mind.
if I can just
Where at?
the cable. It can't be tethered. It can't be tied down. I gotta get a good jimmy.
The timing was kind of specialized because they like acquire the position and then you lock the position and give you more accurate time somehow. Like I don't know. I mean they're just specialized from the software side. Question side.
It's nice that it's just power.
Yeah. Although I guess if you use both channels, you might need to connect power supply.
Yeah. Because the roll becomes right now, like if you connect it,
Probably not if you use a Mac because Mac USB standard is like half an amp. But USB 3 has more power.
Yeah, come on.
So if I wanted to spend like $4 grand, I could buy like some Altera.
I mean, is it directional that I don't have to like pay attention to?
I don't think so. I don't know if he's using that for this. I think he's using his iPhone, his old iPhone.
How many computers?
Takes three not weak computers to run. Hopefully it's safe.
At least to work.
There's handset, PlayStation, actual like modem. It's three. There what?
The soft handset.
Well, there's one running there. Well, there's one running here.
Oh, is it your home?
No, I'm not gonna. I mean, it's just visualization in this case. It's running. It's actually spitting out the wire chart.
Wireshark. I heard that before.
With root permission?
No, without.
No, that was JRC.
What? Right.
No, we were talking. We were doing the B200 piece stuff. Just run it.
might get started again.
Outside, I saw the I mean, in general, the thing is like
We might get started again now, and head over to our third speaker. Tom Zhu is going to talk about the current state of LTE with software-defined radio. So please take it away, Tom.
All right, thanks, Bob. So we have a lot of stuff going on today. We have, there are 3 desktops running this presentation, despite the 5 boards that you see up here, so hopefully all goes well. I'll have a little bit of demos, and yeah, cool stuff with the LTE. All right, so what are we talking about? This will be a fairly non-technical talk. There's a lot of content for LTE. It's kind of a glance over just to get a feel for a lot of things. Basic architecture. We are in an SDR talk, so we're going to be mostly covering on the interface. That's the cool part. Security implications. I know you people are out there. I get it all the time. So we're going to cover some just kind of where we stand, some general, again, just pretty basic aspects of LTE security. And then moving on, that all preps for what's out there now. What's the LTE software that we have that you can run on usurps, RTL dongles, et cetera, et cetera. And we'll show some stuff at the end because demos are cool. All right. Architecture. So I talk to a lot of people about wireless and like getting into LTE, and a lot of people often come at this from my perspective. They want to run YouTube on their handset. They look at like a Wi-Fi box. You set it down. I suppose you can get usurp. Maybe you can really expensive test equipment, and that's kind of it. Maybe you get an IP address and you start talking, but that's not how it works with LTE. There's a lot of moving parts. Historically, it comes out of telecom. Telecom is a massive, massive beast. National regulations, history, obviously the actual physical telephone part, going way back, GSM, late 1900-ish, ISDN. GSM was heavily based on ISDN for aspect. You don't have that on a purely IP thing, but yet we still see these moving to LTE. We still see this telecom influence on a lot of the aspects. Billing and roaming, thinks about that for Wi-Fi. If you're on cellular on LTE, you are very well aware of data roaming when you travel. And another example, SMS. SMS IP based, not at all. It is strictly cellular concept. So when you start comparing this to Wi-Fi, there is no equivalent. There is no SMS for Wi-Fi. It's not equivalent. Okay. And about that architecture, how is it different? We're mostly going to talk about the interface today. The interface, the think of the SDR, the OFDM, that's this right here. That's this user equipment to eNode B, that's the base station. And using the example, if I want to watch YouTube on my phone over LTE, it's got to go through authentication. Again, not like Wi-Fi. It doesn't authenticate against the box in your room. It authenticates with the network, the MME, the subscriber registry, and being read. And you have to go through all of that to actually get to the internet. Again, that's not really the focus of this talk, but I just want to be aware, especially when we think of the packages of what's out there. Some parts will only implement this. You might get a link. You might be able to scan yourselves, but you're not going to be getting YouTube on your phone or anything. So with that out of the way, let's just kind of go straight at the SDR aspect, the interface. It's complicated, but fortunately, in my opinion, it's not nearly as complicated as WC, the 3G standard. And we've seen this, if you work in wireless, you've heard this exponential user growth. We're running out of spectrum. The FCC needs to reallocate spectrum here, spectrum there. We're going to hit this wall in, I don't know what the, 2020 or something like that. You guys have seen it and heard all of that. So here's a visual representation of how we really change when you go from LTE perspective, spectrum-wise. GSM is, in comparison, just kind of looks like a tone at this point. This is 32 megahertz wide on this particular plot, and 20 megahertz LTE. Even WCDMA looks pretty small at this point. Now, in terms of signal processing, SDR, why does that matter? Why don't you just run your QPSK, whatever your single waveform, just run it faster with more bandwidth? And the big reason there is it's hard. Fading. Fading is proportional to how fast you sample your bandwidth. And especially at higher band, we're looking at 20 megahertz per LTE. And you need to, your signal goes over the air, bounces off walls, who knows where it goes, but you get a very distorted kind of signal at the end. And traditionally, you do that in time domain. That's just really, really hard. I'm not going to go into the details, but it's really hard. It's nonlinear. Nonlinear things are hard. So OFDM, how that works is we just break up that big swath of 20 megahertz into much smaller narrowband signals, and we kind of just, well, if they're narrower, then we don't really kind of get the same effects. It's a bit easier to deal with. We can deal with that in the frequency domain. It's much easier to handle. Why that is, and here's where you kind of start getting into some activity. And this is an example of fading. And that's one thing I want to get across, why this is much than in the frequency domain than a traditional time domain system. This is a 10 megahertz LTE signal. The channel response going from a usurp base station, this is running, to my antenna that's happened to be laying on the floor right now. In this case, we have about 1 meter or so of separation. So the channel, this is the magnitude response. It's pretty flat. I mean, this is kind of like a close to ideal case here. It's just a flat channel. We don't have to do anything special in terms of equalization. We have some interference. I have no idea what that is. When I plugged everything together, I saw it. I didn't care. Just to note that's there. Can everybody see that? Okay, it's kind of light. Or should I get the lights? All right. So that's a with 1 meter distance. And to see the effects, I have the antenna, which was on the floor, and base station in this corner, usurp here. I have an antenna, and suppose I just stick it in my pocket there, and it's pointing at the base station. And you take a phone out, you stick it by your ear, and then look at all these changes, channels changing really fast. You have to equalize for all of that. You have to manage that. These effects will all show up in the constellation, and this is 2 meters away from the base station. You figure going into a car, walking down the street, down a busy alleyway, city structure, or indoors like here, or heaven forbid you're in 60 miles per hour in a car, and you start getting these effects. And again, equalization, you have to cover all of them. You have, when you do your constellation, you have to at least and basically even out all these things. Otherwise, your constellation will basically look around. So, equalization, OFDM, wider bandwidths, it's a really big deal. And the fact that we can do this, it's frequency domain. So this is actually just coming out of a receiver. And one way to think of it is, with OFDM, you do a lot of FFTs. You're actually doing 14 FFTs per every millisecond. That's kind of a built-in spectrum analyzer. If you know what your spectrum is on your channel from your reference signals, then you can basically correct for all this activity. Questions on fading? No, that was fading. All right, quick shout out here on a separate note. There's a lot of information on LTE. Even pesky details like how do you go from being these embedded frequency codes to an actual frequency value. There's a really useful site. It's just out there. This is somebody's personal site, and if anyone who actually owns the site, I'd like to buy the person here because it's really useful. But I put that one out there because this next chart actually comes directly from that site. And this is a time frequency plot for LTE. And that's how you do multiple user resource allocation. In GSM, everyone transmitted at a different time. In CDMA, everyone had these coded signals, which I'm not going to get into because it's too weird. In LTE, you separate users by time and frequency. X-axis frequency, y-axis is time. And I'll break out a few of these pieces here. I showed you the channel. You know the channel response? Because there's these embedded reference signals. You know what those are. Compare those with the signal you receive, you have the channel. And you basically invert it. And that's why equalization with OFDM is much more of a pleasurable experience. Some control region, there are some synchronization signals. I want you to pay attention to this blue guy. I just kind of put it in there by myself. So the base signal will be transmitting when you first look for a cell. It'll do some acquisition stuff, configuration. It's going to look for the system information. Who am I? Maybe what time it is. So keep an eye out for that one. And show that chart out there, but you know, what does it really look like in a live sense? You pull these spectra, and you want to know what you're actually looking at. So again, we can kind of look at that live. I'll give you some. Let me move the antenna here. Oops. Still don't know where that interference is coming from.
You know what frequency is that?
It's around 2.654 or so. It definitely popped up when I was basically setting up. It wasn't up there initially, but anyhow, you'll have to make do with interference there. Real life RF, deal with it. So I mentioned those reference signals. Always transmitting reference signals. So when you look at your phone, how much you see 4 bars, 3 bars, 2 bars. I mean, what does that really mean? Details, you might get a dBm value. What does it really mean though? It's these values. Always transmitted. So you have this reference, and you use it for. The phone also uses it to know how much power it's receiving. And straight down the middle, synchronization signals. And I mentioned this guy right here on the side. That's the system information. And that's really kind of the secondary stage of the phone kind of the handset will synchronize, and that's the first time it really gets real information about the cell is in these blocks. There's another information block in the middle, but out of brevity, I'm not going to really say much about it. So that guy right.
So Tom, this tangentially related, but IRC is asking how you doing the graphics.
So the graphics are, there's actually a receiver running on one of these PCs, and it's actually synchronized that way. And the graphics are actually plotting through QWT. In that the FFT, there's 14 FFTs per millisecond going on in a receiver. So what you're actually seeing is receiver spitting out the FFT directly into an XY plotter. And I'm sure I'll get the question of what software is it. Unfortunately, this software is not open source. It's some internal software that I've been working with. Plan is to open source it at some point, but unfortunately, I can't really give a date on that. So as far as what it is, though, it's a receiver software, and it's plotting through a UDP socket going to a QDP or QWT plotter.
So there's like a 3-minute delay on. So if you get follow-up questions,
Okay,
I'll
sure.
ask you them in 3 minutes.
Yep, that's fine. So that's what LT. That's an idle channel, live, and the only thing you can kind of see is the system information going through. So what's in that? I mean, it's what's in there, and this kind of gets into some, let's say, some security implications a little bit. Here's an example. There's actually a bunch of stuff, but this is one. What time is it? In that block, there's a SIB16 is system information block. 16 is a specified case. It has UTC and also sometimes GPS-based information, and it's just out there. It's not. You don't have to authenticate or do anything. It's just there to get. So that's out there. What time is it? And probably one of the other interesting ones is on the handover information. Here's another system information, another one of those blocks that we saw fly. And system information, this one has some stuff of how do you hand over to UMTS? You know, you can, it's pretty amazing. We can do all these things. We have LTE to 3G handovers, LTE to GSM handovers. But you know, how do you know how to do that, or what are your parameters? Well, there's stuff like this in that system information. In this case, we have a priority of 3, and that's how you really compare these things. Let's look at another one, another system information block. GSM. And by these are all, I out of the other day these are all just, I can't tell you whose they are, I just pulled them out of some random signals I saw. And GSM, yeah, it's still there. And in this case, we saw before it was 3, this priority is a lot lower, so the handset's not, it's got to be in a pretty grim case when it goes down to GSM. It's got to have no LTE, no WTMA. And what does that really mean? Handover one's in there for a reason. And we look at some of the security things. I think at this point, everybody's heard of the Stingray. It's been in Wall Street Journal, New York Times. They've made all sorts of news that I can't imagine. And to kind of describe what that is, it's really probably the largest single security hole in cellular. It probably ever will be, possibly. And it basically works on the fact that in 2G GSM, you don't have mutual authentication. The handset is authenticated network, but on the other hand, the handset actually authenticates the network. The network is always trusted. And it kind of seems crazy now, but the reason for that, you go back into late 90s when they were really building these first GSM systems. The thought of somebody actually building a base station, a rogue base station, was so absurd. I mean, it's like going to a bank and having to authenticate because a bank might be fake. You know, it might be a fake building. You don't. That's absurd. You don't think of it that way. But that's how it was when they were designing GSM. So, but they did. So there's no authentication of the network. It's work. And being closed. I mean, that authentication didn't really happen in 3G. But the fact we still have 2G, they do still exist, and these systems, obviously, you read in the news, they're out there. So what does that mean for LTE? I told you that you have system information, handover information priorities. Those are all broadcasted and clear. Those are not ever questioned by the mobile. So, whereas you can't really directly control the handset like in GSM, the handset authenticate, or the network authenticates the handset, it basically takes control of the phone. That's just kind of how cellular works. The network has, as far as allocations, the phone transits when the network tells it to. So you can't really do that with LTE with the authentication, but you can manage that the environment, that system information I talked about, that handover information. That's all still out there. That's not behind the wall of authentication. It's just out there, and it's still pretty much trusted information. So the phone can't be really directly controlled anymore with LTE or 3G really, but it can still be environmentally influenced and coerced in some cases. And sometimes you can push on 3G, and in some cases, where again 2G is not authenticated. So that's still out there. So that's kind of like section 1. That's just kind of a visual overview of kind of LTE kind of crash. I wouldn't even call it a crash course. It's too short for that. And kind of the rest of it is just kind of looking at some of the LTE options in terms of software. Any questions at this point? Anything from IRC land? Did they not like my previous answer? All right, so we'll just keep on going. So LTE cell scanner. This is so we'll kind of go through these kind of. Like I said at the very beginning, there's a huge amount of LTE in terms of the network. We'll kind of start at the ones that do the more targeted functionality, maybe just an interface, that will eventually get up to the full implementations, the full YouTube. So LTE cell scanner. This is something written by James Koulis, and who now works at Google, and he basically wrote this thing up, and what it does is it does really the very initial parts of LTE acquisition. And the main is the master information block. I didn't really cover it too much, but there's a CRC check on that. So when you get this far, you basically have a confirmation that you're attached to an LTE signal. And that's really what this does. It gives you a really confirmation when you're scanning that you're not just looking at rogue tones or a microwave or anything that might have just triggered out some kind of response. So you have stuff like this. This runs on the RTL SDR dongle only. So yes, you can do LTE things with a pretty cheap little device. It is possible. It's not all expensive, although most LTE things are. Moving on, GRLTE. This was a graduate student project in KIT, Karlsruhe in Germany. And this is similar to the cell scanner, and it does that initial attachment coding. So you get a CRC check, and you know you found the network, and you're just not looking at crap out there. And the advantage of this one is it runs in GNU Radio, and then there's actually GRC blocks for it, and then that's kind of really the big benefit here is if you want to get a very visual breakdown of the blocks, the pieces, how the LTE parts work, then this is kind of the one application out there that does it. Now, given that I will say that LTE or cellular in general is pretty particular, you don't find too many. In a lot of cases, you don't find very much reusability because you wind up down everything very specific, like channel coding, for example, and LTE turbo coding. It's a very specific turbo code. And optimizing and things like that, you find that it's not usable or not portable to something outside of LTE. So you don't find too much in terms of like basic GRC blocks in some of these LTE apps, but GRLT is kind of the exception there, where a lot of the blocks are custom, but it is based on. And as we keep on going on, OpenLTE. This is probably the first kind of open source LTE. Probably the package that I remember. I was actually in grad school when this one came out. It does use GNU Radio, but not really in kind of a GNU Radio block sense like GRLT. It's actually one monolithic block. And advantage of some of the hardware attachments to GNU Radio, but for the most part, it's an encapsulated piece. It just happens more like attached to GNU Radio. There are a handful of things in there. Octave simulations. It's as far as open source software. Then the author pretty good credit. It's fairly well documented. Octave simulations. There's some file scanners. There's some over-the-air scanners. My personal feel that the big advantage here is really the completeness on. I showed at the very beginning, like you need a lot of parts to get all the way through. If you want IP access, you can do pings. You don't just have an interface. You have all those elements I showed earlier, the MME, HSS, those aspects. And Ben has quite a few of those in there. So this is at a state. Last I recall, you can do things like pings, probably not do FTP transfers or really high amount of volume, but there is a very basic set of functionality that's already built in. So that's a useful. Next, SRS-LT. This one is a project from Paul Sutton out of Ireland, and it's kind of a spin-off from College Dublin. This is
related to libLTE.
very good point. Formerly known as libLTE, I should have put that on there. But formerly known as libLTE, now known as SRS-LT. And
Research.
software. It's the name of Paul's consultant.
I did Paul
Paulson. Okay. I'll take your word for it. But yeah, so this is mainly looking at L1. So this really is focused on the SDR aspects. There's no actual core part of it, but they do have a pretty nifty demo set up. They have some software tools for the GUI, and they have a video. So one thing you can do, like I said, you need a lot of pieces to get all the way out to IP and YouTube. But at the same time, when you have a link, you can just ram packets data over it and kind of pretend like you don't even have a Mac or even kind of multi-users. And that's kind of what they did here. You can put video directly on the LTE 5 lane without having all of the radio resource control and all these other layers of LTE functionality. And moving on, we have interface. So another large project out of Eurocom in France. They have a lot of functionality. So mainly focus on Enode B, and they also or a functional EPC setup. There's a lot of development going on this one, and at the same time, it's also may not be the easiest setup to install because of the huge amount of features, functionality, and also that pace. So there's a lot of changes going on. So it's not necessarily the most upfront and easiest thing to set up, but again, they do have quite a bit of functionality there. For example, they have a nice GUI that we can kind of take a look at here. And last, we're out of level order here. Well, last but not least, Amerisoft Enode B, and who is that? Looks familiar. So Amerisoft LT is a functional LT and EPC. Now the key thing here is commercial software. I don't know what current price. There will be a comment in it. And they have a lot of functionality. FDD, TDD modes mainly used in China. I didn't really talk about that, but a lot of functionality. And they also have an EPC, the MME, with the built-in components that you can actually, for example, the Amerisoft core network with something like the open air interfaces that I showed previously, and that's actually been done. So it's actually a tremendous amount of functionality there, but again, it's not a free piece of software. So it is cheaper than like certainly a base station, but or any kind of test setup from one of the traditional test vendors. And that said, let's kind of switch over here. We had a live network running before, and it's still there, unfortunately. TV switched up. Where's the?
Is it on the side of the TV?
Still need the. Oh, there we go. All right, so what we have here is, I told you there was a base station running in the corner. That was actually the Amerisoft setup. Also running in the corner is basically a Windows setup, and it's one of these guys. This is an LT dongle. It's AT&T, and it's you don't see these as common anymore because Tether for a lot of cases, but we have one of these running, and it's running here. And let's see if I can do anything else. So we have Jimmy Kimmel on the screen, and we're taking a view of that previously idle channel. Now we have a lot of stuff going through it. Some interesting things to note here. This will kind of settle down eventually because we're streaming video, but video is actually not really streaming. It's actually pretty bursty. Go ahead.
What are the axes of that display?
So we saw this, it's kind of that block when I showed earlier. So we have frequency this way, x-axis, or x-axis, and then y, we were seeing it's a spectrogram, so going up and down over and over again. And the frame is kind of actually cyclic, so we see these same pieces in the middle, these sync signals repeating over and over again in the middle. And everything else you see is the traffic. Over there, that's what you're seeing. Everything else is Jimmy Kimmel. And I mean, and like I said, it basically goes kind of on and off, and the streaming is actually really, really, and that's just kind of the thing with streaming in general. It's actually not streaming.
From what you said, that implies that it looks like you've got variable packet length and the frequency domain. So that looks.
Yeah. So that's going to be resource allocation. That's really up to the base station to decide as far as
So
where.
it's actually doing what it looks like it's doing. Okay.
Yeah, it's actually it has packets coming in, and it allocates how it feels, whether it needs to go a full chunk, a large chunk. That's all up to the base station.
So this is to the cellular network. So I guess once.
So this is the downlink. So this is actually going down to the dongle, and it's streaming the video on the downlink.
So we're seeing the local signal, but not any other.
Yeah. So you're not seeing there's only, this is a closed system.
This is a private network.
Yeah.
Oh, okay.
Yeah. So you're not seeing any feedback, and I don't have the up. I can only show one at a time. So yeah. So this is all the downlink traffic coming in, and because it's one user, that's all I need from the video feed on YouTube.
So this is a LTE channel that's not used by local phones.
Yeah. This is a close. We're yeah. And this is also we're in the middle of the industrial building, so it's pretty well. And like I said before, we have 1 meter of separation between the antenna. You don't get it. The random antennas I picked up, so you won't get very far. All right. Anybody else?
And to be clear, this is running on Marasoft.
Yeah, so this is Amerisoft, and the visualization is it's basically passive visualization you're seeing. So this is obviously not pulling data out of the sky. I have no way to do that. So this is seeing it on Spectrum and getting the activity. And we see that interference pop up again.
How wide a channel is this?
10 megahertz.
So what can 10 megahertz of LTE support in terms of data rate?
10 megahertz. Data rate, assuming you don't get into crazy combinations like spatial multiplexing, be in the 30-ish megabits per second. Now that's peak rate.
Sure.
So these are all peak rate in terms of LTE speak are not practical.
Okay.
It basically means heavily or very lightly coded and then highly punctured, really highly punctured. So it really does involve. It's almost like a lab testing setup where you'd really hit those rates.
How many channels are used concurrently typically?
Define channel.
One of these 10 megahertz channels.
So typically all over the place. So the applications you'll see 5, 10, and 20 megahertz. 20 megahertz is pretty massive, like macro cell level. That's a lot of bandwidth. That's a lot of users. 120 megahertz channel, depending on configured, you'd be looking at a football stadium kind of type of application. I mean, it's a very wide and they can support a lot. For 10 megahertz or 20, I mean, it comes down to cell planning. There are also smaller ones, 3 and 1.4 megahertz, but those are quite uncommon on the narrow side.
Colin, do you want to talk about carrier aggregation? Kind of already on that topic.
Yeah, I was going to go into that, but since you mentioned
Up to
it.
you.
So basically, yeah, the peak bandwidth on LTE is going to be 20 megahertz. But you start getting into more recent releases, release 10 specifically, you do have the option of basically looking at taking multiple 20 megahertz signals and actually receiving them all in the same handset. And in that case, you can basically stack carriers. There's options for doing that within the same band. There's also options for doing that in different bands. And one of the more recent things is there's the option of doing that in the unlicensed band. It hasn't really happened yet, but there's definitely a lot of talk going on there. So you have these multiple allocations all being received, so you may have 40 megahertz in total, but it's a non-contiguous kind of. So that's the gist of carrier aggregation.
How does your dongle authenticate with the cell?
So the Amerisoft software does have a core network into it, and it does do the full authentication. So to do that, you have to know the private key on the SIM card, and this is why, going back to the authentication with GSM, you can just put anything on any phone. There's no authentication. Anything will attach to it. But when you work with LTE or even 3G networks, you have to know the private key, and then the network has to know the private key. And because if you take a random SIM card, you don't actually know the private key, and you can't get it off a SIM card. You can't physically pull it off an actual SIM. That's basically from the SIM manufacturer. But the authentication means that stored private key has to match the value of the network. So in this case, we control both sides. So we have a known SIM card, and that's what we do. Card with a known private key, and that's how we do authentication. And it is full authentication. It does happen.
So do you program the SIM, or is a known SIM something you?
So in this specific case, you can do both. In this particular case, I'm using a test, so it just has a known value on it. But really, both cases, yourself or you have basically SIM that has it on there, then both the same defect is same in the end.
You're saying private key, but is it asymmetric or symmetric? Like both sides know the same key?
Same key. Or to my understanding, basically I have basically a test SIM, and I have information on what the key is, and I put that key into the actual network side. That's what I do.
In terms of a single carrier, which we're looking at, and resource utilization, how many users could you have on this channel?
So the question is not really about, if you talk about capacity, and I assume you mean like processing capacity and load and how you get there.
How many users can you serve with some sort of reasonable rate given all of the resources in this channel?
So the main issue isn't
And the
necessarily
scheduling.
the number of users, but the amount of bandwidth, because you can allocate users to different. At the end of the day, you have a fixed set of blocks in the time frequency grid to allocate. And whether you allocate everything to one user and just have them take over the full bandwidth, that's one type of resource allocation. Not a very efficient one if you have 1,000 users, but it is a allocation. And that's not specified. That's the implementation dependent by the vendor.
How about if it was just voice?
That's a good question. It's LTE. There is no voice. Well, at least in the general sense right now.
Right.
So so if you pick up your phone, if you take up, at least certainly my phone, if you go on an LTE network and put a voice call in, watch it, it goes to 3G. It goes to switch voice right now. Yeah, and of course that's in progress. There's voice over LTE, but that's a very fragmented type of system. There's still not exactly full consensus on basically standardization of voice over LTE. So I'm on T-Mobile at least right now. When I make a call, it actually does. You can watch it switch over to 3G. And that's all this is done now. All right. Anybody else?
Can you tell us about why
You're gonna
it's
ask me about the interference.
no, why it's losing sync or rolling a little bit?
Oh, yeah. So The visualization is really just a UDP pipe going to a QWT plotter. So it just happens to be, it's synchronized based off just internal QT timer on, I forgot, 100 milliseconds or so, which it's not a fully real time. There's UDP, and every now and then you'll just see a glitch. There's not really much else to it. Anything else from IRC land?
So there's a question in IRC which recommended software for research, and I asked guest 9915 to refine the question, but he has no answer. I don't know, but if you have any comments.
Yeah, that's a tough one. I mean, so the current savior, I'm assuming he's referring to packages, because certainly Amerisoft is an excellent resource for research. Agilent and Roden Schwartz are also excellent sources for research use, but all of those solutions are a bit expensive. So on the open source kind of encounter, I mean, most of them are kind of a little rough around the edges at this point. What? Yeah, true. I didn't choose it. That was YouTube.
Sure.
Come on, but yeah, it's a tough question to answer.
Yes. Please stop the video.
I'm gonna stop that and answer the question.
What question?
Just go to the next video.
We'll do Brazilian wildlife. It's a little not quite controversial. We'll see.
Brazilian wildlife, yep.
All right. But seriously, going to the question as far as like what's the best package for research. I touched. I mean, it's so kind of expansive, and it really depends on the applications and what people want to do with it. Some people think of research in terms of, on the security level, maybe IP, and they're not terribly concerned about the SDR aspects. So that's one angle. If that's concerned, it's pretty tough right now because it's nothing's really right now to just give me LTE and talk to my phone. Most of the projects I showed here, in general, are on the physical layer. So research in that aspect, like I said, most of them are still kind of rough. If you really want to use GNU Radio, if you really want to use GRC, then GRLT fits in that slot. If you're looking at acquisition, there's the LT. And you have the more complete ones at the end. So it really kind of varies. There's no good answer as far as which one is kind of the best. I think right now SRS LT is probably the easiest to pick up and run with as far as just out-of-box visibility, I think. That's my feel. But in total feature set on the open source side, that would have to be open air basis on the total list of things that it's capable of, what they are and what they set up.
So there's another question. Is it possible to operate LTE base station without going through legal hoops as routine?
Hoops, that's also legal hoops in what sense? If it's a spectrum question, you can operate in a closed network. If you have your own R, you can do whatever you want if you're not transmitting outside of that. So other than that, I mean, there aren't any spectrum is spectrum. You still have the same limitations. If you're not allowed to transmit in some band with GSM, you're still transmitting with LTE.
Nothing.
Am I being attacked?
No.
There's some foolery going around here.
Just testing the robustness.
LTE is pretty
of the link.
robust.
So
Another advantage of wideband access, you do become robust in narrowband interference.
So I'm going to rephrase this question. So can you sort of set up an LTE base station the same way that you can set up a Wi-Fi base station? I mean, not exactly the same way, obviously.
You mean in a legal sense?
Yeah.
Not if you wanted to use like handset on it, because using a handset's going to operate on. You can't pick up an Android phone that That's a good sign.
It just has like 5 minutes buffer.
Anyone else while Ballin mounts an attack?
It's also interesting.
So if you look at the buffering there, it's has that. If
I can pull it. I can just.
I mean, you can see it's not terribly busy, right?
Yeah, I can do another. We can switch to sharks. Because we all love sharks.
Do we have laser shot?
Laser
yeah, it
shot.
has hybrid AI.
Alright.
What about just some general noise in the channel there?
You're too narrow.
So another aspect here, LTE does have adaptive modulation, and in the grand scheme of things, YouTube is actually not ultra high bandwidth. It's not the single stream. It's not multiple users. So certainly in a case like this, before it was probably operating at it's 1 meter distance. It was probably operating at 64 QAM, and you do have the option of 16 QAM and also just QPSK, or QPSK with a lot of coding gain. So it has basically an adaptive mechanism that does offer a lot of redundancy.
Your synchronizer held up well. Your synchronizer held up well.
Well, it does have. I mean, it's on the ground, but it does have 2 meters of distance on it.
That's it? Is that jumping around, that's jumping around in the frequency, right?
Right. Yeah.
The line
It's
is-
sweeping.
It's
It's sweeping in frequency. And we can see Ballin's pattern generation skills going on here.
I'm just using Sigling GUI with sweep different rates. Interesting how it affects your plot there.
So when you're doing that, we can swing back up to the. Yeah, somehow. Yeah, you can see where the frequency effects will affect the channel.
That's really cool, Tom. Oh, would you mind going back to the channel thing for a second?
Yep.
Just bring in some general.
So will there be just be 20 minutes of this next
Oh, you got it.
month?
Yep.
No.
Seems to be really popular.
So it knocks out your synchronization when it gets
Yeah.
quite loud. Yep. It's impressive.
Yeah, sharks do put up a pretty good fight. How do we look here? Oh, that's pretty ugly. And you got it again.
So Tom, you think they'll actually start using LTE for anything?
It has its benefits. But anything in what sense? No, there are. I was thinking there are the other cases. I was thinking you might get into, let's say, public safety. And that's a big can of worms. I'm not going to go there.
Just because it's ubiquitous now, so it's like.
But yeah, there's talk about basically the public safety is a crazy one, and it's not really meant for the original purpose of LTE. So there's thoughts of basically putting in that. It's kind of scary because it's pretty drastic changes. Public safety, so device-to-device kind of access, infrastructure, disaster kind of scenarios. I don't know. Anything else, or do we continue watching shark videos?
I think we've had our minds blown by all these amazing visualizations and things. I think that's pretty good. Do we have any other questions from the audience? No?
It's very cool to be able to visualize it and see it happen.
So what's next?
So LTE is kind of a never-ending beast. The features are never fully implemented, even in commercial networks, so there's always something. But certainly, what I'd like to see is in terms of implementation is more on the upper layers. What we see here is just kind of on the receive side. But like I said, if you want to kind of get to the point where you're getting IP, YouTube, that kind of thing, you have a lot of MAC layer, upper layer, authentication, and all these protocols. And, I think that's actually where the hardest part in a lot of ways is in the LTE space right now. Complexity gets pretty crazy, not even considering the SDR part. But again, you need all that stuff to get IP and watch videos and stuff on YouTube.
What period of time are we looking at there?
So what it is, it's actually the timer. Like I said, I believe it's set on a 100 millisecond interval. So basically, it just has UDP data coming in from buffers it up and just plots it every 100 milliseconds. That's why, and the LTE frame size is 10 milliseconds. So that's why you get this basically almost cyclic behavior. It's not perfect because it's UDP and it's just basically a sleep timer essentially. So it's not necessarily the most accurate thing.
That's very cool.
Is that the yellow leakage you're seeing right in the middle there?
Yes. Fortunately, it's not used.
All right, great. Well, let's thank Tom. Excellent stuff. All right. So we'll conclude tonight then with our final speaker, Kevin. You want to come down and plug in?
Push the button for the projector. Yeah, there's kind of a lag on it, but
go for it.
Can you give the VGA a wiggle?
Looks like you only got two color channels going.
Using your Mac, your Mac's that range is Mac, right?
Old enough that it doesn't have its. Okay, so. Okay, so I was going to give you a better demo than this, but it crashed, and that's what I'm here to talk about today. Okay, who here thinks they are an adequate C++ programmer? Okay, okay, you're the audience, because so this is my Shiny SDR. It is perhaps the other thing I have ever. That's not saying a whole lot, but it sure has a bunch of stars on GitHub, and it is completely based on video. And what I'm talking about today is what this could be, what we could do with GNU Radio to make this even more awesome. Because what I am finding is that if I were to try to characterize GNU Radio, I would tell you it's it's the software equivalent of test equipment. It is not great for actually building an application on. For example, as I said, the server I left running at home crashed, and it didn't, and my code is all in Python, so it shouldn't really be causing that. and I was going to plug in the HackRF, and that suddenly stopped working, you know. But of course, we can all complain about things crash, and it works fine on my machine, right? So let's look at some more specific things that I could, for example, talk about. So we can see here we've got a spectrum display, and let's turn up the gain a bit. So this is, see, also, this was supposed to be, it's missing some fill that it was supposed to have, which is my fault because it didn't work as GPU. But, so, you can see that this is running at 120 frames per second on the waterfall. Now, if you go look at try GQRX, which I consider to be my competitor, or at least it's what inspired me to write this software. If you turn up the frame rate, the reason it won't work is because it uses standard GNU radio blocks for taking your signal and slicing it up into chunks to run the FFT on. Because the way that works is it will not give you chunks, which you need for a high rate spectrum display. And so I am using a huge, which makes this actually work, but it actually, if you look carefully, you'll see that it's a little choppy, and that's not because of the frame rate it's displaying at. Well, it's a little, but because that hack ends up chunking it. And you know, if we had a better system for taking FFTs, overlapping FFTs of the display, this would be a really awesome display, but it's not. But you know, you can't do some things like with the frame rate. You'll notice that, so we've got here this FSK, this narrowband FSK signal. I suppose it's probably a pager. So let's zoom in on this a bit, so you can see. Let's wait for it to come back. Okay, so you can see I'm actually using. So this green line is the average, and the faint red line to be faint except where it matters is actually the completely unaveraged display. So you can actually see the alternating peaks include. This is FSK and not two separate carriers, which the waterfall can tell you that too, but it's not at all easy to. But it's not as easy to get that information from here unless you get vertical zoom. If you want more vertical zoom, well, we need more overlapping FFTs. And obviously, this is still so. So I'm saying this could be better if we had better tools. Now this is obviously not in GR Phosphorus class. If you've seen GR Phosphorus, it's the same kind of stuff we were just seeing with the LTE displays. Really high detail displays. The difference between that, what I'm doing here, and that is this can work over an internet. This is actually, as you can see, this is running inside Chrome. It's in web browser. It could be remote. It's actually not remote because you can see it says localhost. And another thing you'll notice is that the horizontal resolution. Let's see. Don't want to get into that. No. Okay, but let me show you a little bit more of what this is supposed to be doing. So the irony is that it in fact works better on my phone. There's supposed to be a little blue fill in the bottom, which is actually derived from all of the frames that it's averaging, so you would get a nice detailed display. Here, let me
I was about to suggest
show that.
Good idea.
Is that good framing?
Come in closer, 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 or you can come right in. Yep.
And here's the one for the other camera. So, okay. So the other thing I was going to demo, server crashed. I can't demo it here because, of course, we are inside a building, which is not great for your antennas. So with this, one of the things I've been working on is telemetry. I'm taking this from sort of the amateur radio perspective rather than the let's hack all the digital systems perspective. So there's a mapping subcomponent which. The reason, initially, you're wondering why are we seeing degrees instead of a base map? The reason is this is designed so it can work completely offline. And I haven't built an offline base map yet. That's a future feature. If this were working, a system that I recently set up is so that it'll actually work smoothly is you can simultaneously display APRS stations and airplanes. Nobody else. So you can see why I'm going here is sort of, I'm trying to build, a sort of a universal receiver, and because everybody else, builds their individual systems, they've got something that, it'll plot airplanes using ADS-B as the data. And it'll even put it on the map in the web browser, but it won't let you do anything else. But and so I've been trying to build here general purpose software, not something that makes a good demo, but something that you can use it for this and you can use it for that. But we need better components. Let me here. I've actually got. Okay, I'm actually plotting the. Actually, let's see. So this is actually the. Actually, there's only we're actually doing one, so we actually do have the flight. So I can't actually demonstrate the horrible kludge. Sorry about that. Let's see. We've seen enough of this. Let's try and jump right over to. Let's see. So, oops, that's some garbage. But here's your broadcast FM. It's more of the way I was pointing out. You can see the average shape of it and the carrier wandering about. So I think I got a little. So I'll. Unfortunately, I did not write a script for this, so I'm being a little rambly. But what I want, the message I want here is, I think that we can build some really nifty software here, and I'm working on the user interface, and I'm working on the architecture for getting all of these things to interact with each other. What I am you've got some spurs there, by the way. Line going the other direction. So what I'm getting at here is, I want some help, and the help I want somebody who's willing to hack on GNU Radio for me. Any takers? Yes, of course. Technically, I some money for this. I have money. I in fact do have the problem of having money and not having time, because all my time is taken up for doing here. So if you are interested in doing this, for the sake of contributing to the open source world, or in fact for some kind of compensation, let me know. I've got a wish list. And as I mentioned at the beginning, one of the things is I wish it didn't crash so much, and that's hard to quantify. But there's also a number of blocks that I'd like to see. Things like just little things like for example, if you want your basic radio feature of an AGC and a squelch together, that seems to be a little lacking the last time just there's bits and pieces from all ends of things, and other features, like for example, okay, so let's say I put my laptop to sleep. I'm not going to put my laptop to sleep. I'm going to do what is equivalent to this, which is I'm going to yank out the dongle. Now you'll notice that it didn't actually explode immediately. But what it won't do is, if I plug this thing back in, it won't keep going again. That would be something that would be nice to have. That's not strictly GNU Radio. That's GR Osmo SDR. But everybody uses GR Osmo SDR, right? Or they should be. It's you really want to be using a hardware-specific driver? No. So let's see. So if I actually want to, where did I get the terminal? So if I were to actually bother this thing, it will, so it'll spit a bunch of error messages on the console. You know what? And it'll spit a bunch of error messages on the console, and it does not communicate this back to the application at all. Or if I'm getting overruns, it will print O's to standard output. This is completely useless if you are a networked application where your user interface is not the terminal. That's another thing. It'd be simple to implement, just, some kind of thing that says, how many times have you overflowed in the last second or something, and that would fix that problem. Or for that matter, one there. You know, it has not seen very much use for transmitting. You know why it has not seen much use for transmitting? Because GR Osmo SDR is incapable to a first approximation of transmit-receive switching for HackRF. And you know, this could be fixed. It's a matter of programming. We just, you know, and well, there, see, crashed. And you know, I'm just saying, there's a lot of room for here. We could be building, you know, we could be building small. You know, and I've seen a lot of this. I've seen a lot of these bugs, and if you think you can help, talk to me. Thank you.
Thank you, Kevin.
So this is probably a really dumb question, but if you have an APRS mapping feature and you are also, and this application is also network capable, is it possible to use multiple applications to map a point source of transmission?
Yes. That, well, for actually, interestingly enough, APRS itself has protocol features specifically designed for doing the job of distributed signal location. I mean, obviously not in an automated sense, but in a sense that there is explicit support for, you know, handing out, you know, putting reports on the network. And so that is a thing that but you can. So that is a thing you can do. You know, the question I almost thought you were going to ask, that APRS is a information broadcast protocol and it is bridged to the internet. Can't we, you know, retrieve information from the internet and plot that along? And the answer is that is something that I am actually working on. Right? The problem is right now my architecture as it stands is great for saying, okay, we have RF sources and we have demodulators and we put that in a display. It needs some work to deal with, you know, getting information from the internet and putting it on, or you know, from sources that are not, you know, actually I work on telemetry is a hack. I'm trying to figure out what the right general architecture is so we can actually, you know, integrate all this stuff cleanly. You know, but the sort of thing you're talking about, that is the sort of stuff I am trying to build here. I am trying to, you know, my original vision was, you know, back when I said, you know, hey, what is the radio thing anyway? And then I got into it, and I'm trying to build the thing I wanted to when I got started here. I'm trying to build a thing which gives you the world, you know, and it doesn't make you, you know, hunt down a bunch of, you know, miscellaneous software and virtual audio cables, God forbid, and you know, all that crap. It's, you know, I mean, I am trying as much as I can to not build stuff from scratch. You know, like the APRS decoder, I did not write that. I use not even a GNU radio block. I use an external program connected with pipes. Works great. You know, so, you know, just program. Come on. Yeah. It's actually quite. I use my own FM demodulator, and it goes out of pipe, and it comes back in as APRS packets. I'd love to do that with even more stuff, but unfortunately, the programs that you can actually use that way are in fact a little thin on the ground. But GNU Radio is a nice source of it, so I am using GR error modes. I'm using, you know, got plans to integrate GR AIS, and, you know, all those kinds of things. If we have, you know, hey, integrate GR LTE, you know, put everything in. Any other questions?
All right. Thank you, Kevin. Any other final questions or announcements before we wrap up? All right. Well, in this case, thank you all very much for coming. We had quite an exciting night. Many varied topics. Thank you very much again to our speakers, Martin, Moritz, Tom, and Kevin. And please stay tuned to hear about what we're going to do next month. It might be a bit of the reverse situation where people that are in Washington get to watch the live stream